Soil moisture sensors can be used to help determine irrigation schedules for specialty crops produced in plasticulture systems using drip irrigation. Sensors can help a grower better understand how irrigation is impacting moisture in the soil below the plastic. Maintaining even soil moisture is important to maximize crop development and can play a role in promoting good fruit quality. For example, the occurrence of blossom end rot on tomato and other crops is associated with a calcium deficiency in the plant that occurs due to irregular irrigation. Soil moisture sensors can be placed at multiple depths to determine when the rooting zone of the crop is being wetted with an irrigation event, when water is moving past the rooting zone, and water is being lost. This information can help determine how long to run irrigation to avoid losses. There are many different types of soil moisture sensors and means of determining soil moisture status, with advantages and disadvantages of each. In this video, we will walk through how to install two aerometer type sensors in a plasticulture bed, one at 6 inches and one at 12 inches deep. The specific brand we are using is Watermark. We are using these only as an example. You should consult your local university cooperative extension service to determine what type of sensors they recommend for your cropping system, climate and soil type, and what depths are most appropriate for the crop. Some of the basics we cover in this video may be applicable to other types of sensors. Some of the tools you will need include a soil probe or a slide hammer that is a close match for the diameter of the moisture sensor, an empty bucket, a bucket with water to hold the moisture sensors, some water, and tape. Step 1. Ensure that the sensors are stored wet or held in water prior to installing them. Step 2. Choose a location in the bed where the sensors will be installed. The sensor should be placed at least a few inches from the drip tape and the base of the plant, and not directly next to where there is an emitter in the drip line. Here, as you can see, we chose the shoulder of the bed approximately 5 to 6 inches from the buried drip line. Be sure to first locate the drip line to ensure it is not punctured when installing the sensor. The sensors should also be placed 5 to 6 inches apart. Step 3. Use a soil probe or a slide hammer to make holes for the sensors, one at 6 inches deep and one at 12 inches. Measuring the desired depth on the soil probe and marking it with tape or a marker can help ensure the hole is not too deep or too shallow. Save the soil removed from the hole to use later. Step 4. Insert the soil moisture sensors into the holes. Label the top of the probes to help identify the sensor depths later when taking measurements. After inserting the sensors into the soil, grout them in using a slurry made up of the soil removed from the hole earlier mixed with water. This helps to ensure the probes have good contact with the soil and that water does not run down the hole around the sensor and give a false reading. A funnel can help direct the soil mixture around the base of the sensor and ensure the hole in the plastic is kept small. Step 5. Test the sensor to ensure it is reading. The sensor will likely read 0 due to the soil around the sensor being saturated following the grouting process. The sensor should also be calibrated for soil temperature. A soil thermometer should be used to verify the soil temperature at installation. Here, we are installing the sensor in an established planting, but ideally the sensor should be installed earlier in the season when the plants are small, in order to avoid damaging the plant roots and to better manage irrigation on the young plants. Step 6. Tape the plastic around the sensor to ensure that overhead irrigation or rainwater does not run down around the sensor and give false readings. Flags placed near the sensors can help locate them when taking regular readings. Spending time installing soil moisture sensors can ensure that more accurate readings are being obtained, which, in return, will ensure better management of your irrigation system.